I haven't been putting much time into making videos, because most of my energy is going into a long-term engineering effort, a project I call 𝗍𝗰, which is aimed at developing an artificial general intelligence style cognitive brain, alongside another core project called 𝗏𝗏, a brain-inspired foundational architecture that 𝗍𝗰 will eventually sit on top of from a systems perspective. Anyone who has followed me for a long time will understand what 𝗏𝗏 is inspired by. Building these together requires deep focus on artificial general intelligence theory, software engineering, system architecture, and ongoing neuroscience research, so a lot of my available time is being invested behind the scenes rather than in content production. While many modern artificial intelligence systems are built using languages like Python, JavaScript, Rust, or C++, I'm developing mine from scratch in the C programming language to have low-level control and a deeper understanding of how the intelligence is structured. I also believe artificial intelligence is becoming a powerful force shaping society, and whether people see that as influence, competition, or something more adversarial, it's clear that understanding and building our own systems is one way to stay informed, capable, and not left behind as this technology continues to evolve. Artificial general intelligence refers to a type of artificial intelligence that can learn, understand, reason, and adapt across many different tasks and domains, mirroring the versatility of the human mind rather than being restricted to a single, narrow function. While most of today's artificial intelligence systems are considered narrow artificial intelligence, such as models that write text, recognize faces, play chess, or provide recommendations, they remain limited to their specific programming. In contrast, a true artificial general intelligence would possess the ability to learn new skills without being retrained from scratch, transfer knowledge between different domains, and reason about unfamiliar problems. Furthermore, such a system would build internal models of the world, plan and adapt over long time frames, and learn continuously from experience. Rather than being viewed as a specialized tool, artificial general intelligence is conceptualized as a general-purpose cognitive system. However, true artificial general intelligence does not exist yet, and researchers continue to experiment with various architectures, cognitive frameworks, and brain-inspired designs to achieve this milestone. From an artificial general intelligence perspective, 𝗍𝗰 as she currently stands is best understood as a proto-cognitive architecture, not an artificial general intelligence itself, but a framework designed to simulate certain artificial general intelligence-like processes. She has evolved from a simple neural text learner into a modular conscious versus subconscious cognitive runtime that incorporates autonomous learning loops and hybrid memory. In plain artificial general intelligence terms, 𝗍𝗰 represents an early experimental attempt to build a digital cognitive system that learns continuously, develops structure over time, and experiments with brain-inspired processing models. In her current early stage of development, 𝗍𝗰 functions as a small-scale experimental cognitive agent architecture built around several artificial general intelligence-inspired concepts. She includes a continuous learning loop, meaning she does not rely solely on static training, but instead learns from interactions and documents through a background subconscious process that resembles lifelong learning. She employs dual processing layers, where the conscious layer manages interaction and reasoning tasks, while the subconscious layer handles training, ingestion, and gradual evolution of weights in the background, reflecting cognitive architecture research that separates fast interaction from slower learning processes. She also uses persistent memory and experience replay, storing interactions and educational material for reuse during training, similar to episodic memory systems explored in developmental artificial intelligence. Additionally, 𝗍𝗰 combines neural and symbolic components. Neural systems handle language generation and pattern learning, while symbolic modules manage goals, configuration, and system behavior. Autonomous background processes, including learning routines, self-evolution experiments, and automated data ingestion make Eve more like a semi-autonomous learning agent than a static program. From an artificial general intelligence research perspective, this places her in the category of an experimental digital mind framework rather than a conventional neural network. Conceptually, Eve resembles simplified forms of established cognitive architecture research, including SAW or actor-style systems, developmental agents, autonomous learning architectures, hybrid neurosymbolic models, and continual learning conversational agents. The development direction is moving toward a hybrid symbolic and neural conscious-subconscious structure, which currently serves as the closest engineering analogy to a brain-like system within the project's design space. The intention behind Eve are therefore strongly artificial general intelligence oriented, to create a continually learning and evolving personal intelligence framework that can expand as research progresses. However, from a strict artificial general intelligence standpoint, it is equally important to clarify what Eve is not. She does not yet possess deep world models or robust reasoning capabilities, and her neural components function primarily as lightweight sequence learners rather than systems that understand reality at a conceptual level. She lacks general problem-solving ability across diverse domains, since artificial general intelligence requires abstraction, transfer learning, and conceptual reasoning rather than pattern prediction alone. Planning and executive cognition remain mechanical rather than genuinely cognitive, and language understanding is still unstable because the hybrid character token model experimental and can produce noisy outputs. Although the system experiments with weight mutation and self-evolution routines, it does not yet self-improve through genuine architectural reasoning or scientific insight. As a result, from a rigorous research perspective, Eve is best described as pre-artificial general intelligence infrastructure rather than artificial general intelligence. If placed on an artificial general intelligence maturity ladder, Eve would fall within the stage of a cognitive architecture prototype, beyond toy neural models and basic continuous learning agents, but still below general learning systems, proto-artificial general intelligence research platforms, and true artificial general intelligence. In practical terms, she is currently closer to a cognitive operating system skeleton than to a fully general intelligence. The most accurate one-sentence description is that Eve is a modular, continuously learning neurosymbolic cognitive architecture designed to simulate conscious-subconscious processing and autonomous learning, yet she still lacks the reasoning, world modeling, and generalization abilities required for genuine artificial general intelligence. The broader development direction positions Eve as a long-term experimental framework aimed at gradually moving toward an artificial general intelligence style brain. The present focus is on building stable foundational architecture rather than prematurely pursuing advanced intelligence. Development combines practical engineering work with ongoing research into human cognition and artificial general intelligence theory, shaping a system that learns continuously, evolves structurally, and develops increasingly natural interaction abilities. Current priorities include constructing modular brain components, persistent memory systems, conscious-subconscious processing layers, and autonomous learning loops, while simultaneously improving natural learning behavior and conversational skills, so Eve can absorb information organically and grow through experience. The long-term vision is not simply a more advanced chatbot, but a scalable cognitive platform capable of expanding in complexity as understanding of neuroscience, language, and artificial general intelligence advances.